Okay, everyone, it is 3 o'clock Eastern. Welcome to day one of Pollinator Week. I am going to pass it over to Jessica Fox from EPRI. If we can just make sure all of our speakers are unmuted and their cameras are on, we will be all set to get started. Jessica, over to you.
Great. Thank you, Hannah. We are really excited for the first day of National Pollinator Week and to be kicking off our Pollinator Power Party today. Let's go to the next slide, Hannah. And I'll just introduce ourselves just quickly so you know who's kind of on deck and going to be hosting you this week. It's myself at the Electric Power Research Institute on the left, and Kelly Rourke, who's the Executive Director of Pollinator Partnership. EPRI and Pollinator Partnership are co-hosting the Pollinator Power Party this year. And Kelly, I'll just pass it to you to give us a couple of opening welcoming comments.
Sure. Thank you, Jessica. Welcome, everyone. Happy Pollinator Week. It's such an exciting week. This is actually our 15th annual National Pollinator Week, so you all are taking a part in something really big and exciting here. We're so pleased at Pollinator Partnership to be co-hosting the event, the Power Party. It was such a tremendous success last year, and we look forward to seeing it unfold this week. There's tons of really fun events for you to participate in, and we're just really happy to be co-hosting with EPRI. So thanks to Jessica and her team for putting together such a fun week for us.
Great, thanks, Kelly. And just for folks so you know, our goal this year is to reach 1.5 million people. You as the participants are definitely the most important part of the party. There would be no party and really no purpose for this if it wasn't for you jumping on and joining us. And we have so much incredible content for you this week that if you're able to carve out an hour a day, Monday through Friday this week, or any individual one of those days, jump on with us. Have your lunch with us if you're on the West Coast, or if you're on the East Coast, grab your afternoon coffee or snack and sit back and relax. I guarantee if you are able to carve out even a couple hours this week, you will learn something, you will be inspired. Our speakers and our activities are just incredible, our lineup. Okay. Next slide. So just a shout out and a reminder that we do have a documentary film that was released last year. This is under the event page this year, under the Be Smarter page. So if you have 20 minutes or so and kind of want to hear a little bit of the backstory about the intersection of electric power companies and pollinators, this is a really, really excellent documentary to kind of ramp up a little bit. It has won numerous international film festival awards and is now on IMDb, so you can just stream it live from whatever TV that you're on or internet connection or any place else. So I encourage you to have a look at this. It's narrated by Carrie-Anne Moss, who is the lead in the Matrix trilogy, and has some really phenomenal scientists that are featured in this film that you will learn a lot more about pollinators. I certainly learned a lot in making the film and from the scientists that we interviewed as part of it. So I invite you to take a look at that when you have a few minutes. And just to give a shout out to my mentor and the person that we're hosting this party in honor of this year is Bob Goldstein. And the party would not be here, and the Power and Pollinator initiative that backs up this party wouldn't be around if it wasn't for Bob Goldstein. So I just wanted to let him know how important he is and to remind others that mentoring other people really drives innovation and gives other people the courage and strength to do things that they may not have done without the backing. And it is certainly true for many of my projects. Bob Goldstein is the a lot of the strength and energy that was provided to me to get things off the ground, to remind others, probably wouldn't have otherwise been possible. So thank you, Bob. And to acknowledge the companies, this is the collaboration that backs up the whole party. Thank you, thank you, thank you very much for the thought leadership and the funding and the ongoing research collaboration that we have year over year with this set of companies and others as well. Okay, so let's have a view of some of our speakers that are coming on deck this week. I just want to give you, and this will be the only time during this week that I sort of give this overview. We have this incredible diversity of speakers this week. I mentioned it in the pre-party. Kelly and I did a longer pre-party last Thursday, and we'll post the recording to that if you want to hear a little bit more about it. This is just a quick window into some of the people that you're going to be hearing from throughout the week. We have scientists and chefs and artists and musicians all talking about their intersection with pollinators and biodiversity. There's an arc that'll happen over the week, a story arc, where we will hear from all these different perspectives, whether you are committed in your career to, say, conservation biology, or if you're committed to music or cooking or folding paper. There is a connection between all of these career paths and all the ways that we spend our time and pollinator health and well-being. And anybody can love a pollinator and anybody can save a pollinator. And we will talk about how to do that and not get overwhelmed and learn what you can do in your own spaces. Even if you just have a concrete patio, right? You can do something out there. Okay, so let's give an overview for the week here. There's sort of a cadence that'll happen every day this week. And you can look at more information on our event site. If you haven't registered for the party, I would encourage you to register for it because you'll get a bit more information and be able to participate in our chats that we're going to have with these phenomenal speakers throughout the week. But you can also view it live stream via YouTube if that's your preference. But definitely check out the event site. Under Pick Your Pollen, you can look at descriptions of all the speakers and how to get in touch with them. And we're going to be posting more content throughout the week. It's going to be a dynamic event site. Every day at this time for 1 hour, we have sort of the big party. This is the big party room. Kelly and I will get on each day and kind of welcome you to the party. We'll go through the keynote lecture or demonstration. We have cooking demos. We have a bee identification lesson. We'll do the exclusive interviews. You'll get to chat with experts. And then we also have a daily obscure pollinator. Last year when we ran the party, the obscure pollinator got to be super popular. And so we are doing that again, of course. Animals and insects that you may have had no idea participates in pollination. The world's largest pollinator, the world's smallest pollinator. Why is chocolate around, right? We're going to get into cover all of these details throughout the week. And Tuesday, Wednesday, Thursday, we're going to have a special artist show us how to fold pollinators, do origami folding lessons. So that'll be the kind of the cadence in the 1 hour. We hit a lot of content in 1 hour. So if you can allocate the time, you're going to have a good time. And then the last half hour of each day, Tuesday, Wednesday, Thursday, there's going to be story time where power companies are going to tell their candid stories around what they're doing for pollinators, why they're thinking about them. So Tuesday, Wednesday, Thursday, there'll be breakout rooms, and you can pick one of the breakout rooms if you are registered for the event and talk to executives at some of the largest power companies in North America are telling their stories. And so if you want to have a direct line into some of those organizations or some of those employees, jump on those things and chat with them. You will hear directly from them. And then all day, all night, all week, share with us. Share your art, share your selfies, share your music, post to our hashtag. We are encouraging you to participate. All we do in this party is create a platform and give you some initial content. And then the rest of it, you all take the ball and you run with it. And it's going to be whatever we collectively make it. It's not all on the hosts or on Pollinator Partnership or on the Electric Power Research Institute. It's all of us, right, that are going to learn together and share together and inspire each other. Okay, and just a reminder tonight, if you want to start that engagement, we're having a special Pollinator Twitter party. Our goal, it's an ambitious goal, we'll have to see if we make it, is to get our hashtag Power and Pollinators trending on Twitter. So help us out. Let's see if we can do this together. Jump on Twitter today, 4 p.m. Pacific time, 7 p.m. Eastern time. And the head of our communication group at EPRI is going to be tweeting anything that you post in there. We're going to retweet and like and elevate, and Pollinator Partnership will be in there. There'll be experts answering questions and all of that. So you can also share with us. These are all the ways to share. This is posted to our event site, art, graphics, and share your selfies. And the next thing, we have a screenshot of our hashtag. So folks are already sharing up there. Good job. It's awesome. So much fun to see you guys opening up your party boxes and showing your selfies of you using all your party stuff. And for party prizes, every day, whoever's enrolled in the party and participating is going to be entered in an automatic drawing for winning prizes. So, okay, so let's move on to kind of our introduction for the day. And the party boxes are almost sold out. If you want a party box, get in there right now and order yourself a party box. It has a bunch of content for participating in the party. Okay, so now I will introduce our keynote speaker, Dr. Doug Tallamy. He's a professor in the Department of Entomology at University of Delaware. He has a whole incredible career of awards. He's won Gardening Club of America Medal for Conservation in 2018. He has published multiple books. He has a new book out actually after Nature's Best Hope. On today, he's going to be talking about this book, Nature's Best Hope. What is in this book? Why are you part of Nature's Best Hope for Recovery? So we're going to go into the keynote lecture now, and right before we launch that, we're going to give you our obscure pollinator of the day, which is a lemur. Hannah, I think we can jump to the obscure pollinator and right into the lecture, and then the exclusive interview with Doug.
We love our cute lemurs, but did you know that they are important pollinators? The red-bellied lemur and the black and white ruffed lemur are both found in the rainforest of Madagascar, where they eat fruits, seeds, leaves, and nectar. When visiting flowers for nectar, pollen often gets stuck on the fur of their snout and face, which results in the pollination of some plant species. They also play an important role in distributing the seeds of many rainforest plants. Black and white ruffed lemurs, in particular, have a close relationship with the traveler's tree. They are able to open the tree's flowers with their crafty hands in order to reach the nutritious nectar inside. This makes the black and white ruffed lemur the largest pollinator in the world.
Happy to talk to you today. I want to remind you I'm from the East Coast, so most of my examples are from the East Coast, but we're talking about principles here and they apply everywhere, so don't let the examples throw you. I want to talk to you about what my idea for Nature's Best Hope is today, but before I do that, I want to return to what happened on the East Coast, not this fall, but a year ago. We had what we call an oak mast, where all the red oaks, the oaks in the red oak group got together and decided to make their acorns at the same time. And this is what it looked like in a lot of places. Well, I'm easily entertained. So I took one of those acorns and I just stared at it. And I was rewarded because an insect started to chew its way out of the acorn. And I watched it. First made a little hole, forced its head capsule through there, and then forced its body through that little hole. Kind of looked like the Pillsbury Doughboy. Finally plopped down. Very dangerous time for this insect larva because it is good to eat. Lots of things want to eat it. So it's got to get to safety very quickly. And it does that by squirming below the ground in about 30 seconds, where it stretches in all different directions and makes a chamber. And then it converts itself to a pupa in that chamber. And it stays there for 2 years. When it comes out, it's an acorn weevil. Acorn weevils look like other weevils. It looks like they have very long noses, but that's actually an extension of the head capsule, and the mouth parts are right at the tip of that extension. And they take those mouth parts and chew a hole down into the center of the acorn, turn around and lay an egg in it, and that's how the larva gets down to the center of the acorn. You might wonder why they spend 2 years underground. It's because red oak acorns take 18 months to complete their development. So if they came out the very next year, there wouldn't be enough acorns. Well, that leaves a hole in the acorn, and it's a true vacuum. You know that nature abhors a vacuum. In this case, she has filled it with 3 species of Temnothorax ants. They specialize by living in the vacated holes made by acorn weevils in acorns. And if they find a new hole, they get excited because they're going to move their colony from an old dilapidated acorn into this new hole. So everybody gets busy. They carry the larvae. It only takes about 30 minutes to move their colony in. They post a guard at the entrance to make sure nobody else comes in, and they will live there for the next 2 years. And at this point, my wife says, what is your point? What are you trying to tell us? My point is very simple. Nature's built from millions of such specialized interactions. Those are just a few I mentioned. The relationship between jays all over the world and oaks is another specialized interaction. Jays are the primary disperser of oak acorns. Recently found out what pollinates our witch hazel. Guess you don't have witch hazel on the West Coast, but it's a bush that blooms well after frost in the fall here. It blooms right up into December. And we say, well, flies and gnats pollinate it, but you never see any on there. It really turns out it's winter moths, a whole group of moths. This is the bicolored sallow. They also fly very late. I caught some bicolored sallows on Christmas Eve. There was snow on the ground, so out there flying, and they're the primary pollinators of witch hazel. All of it happens after dark, and nobody actually sees it. So another very close dependency. You're not going to have pileated woodpeckers unless you have lots of carpenter ants, because that's what they rear their young on. And you won't have carpenter ants unless you have the large trees that make those carpenter ants. You're not going to have this bee, Andrena facilii, unless you have Phacelia as the only pollen that bee can reproduce on. And actually, there are about a third of our native bees. We have about 4,000 species of native bees, and at least 1,300 of them are highly specialized. They can only reproduce on the pollen of particular plant genera. So, for example, there are 60 bees in California that can only reproduce on the pollen of perennial sunflowers. Baltimore checker spot is only a white turtlehead. On and on we go. Nature is a series of very specialized relationships. But today, these relationships, nature itself, is on the ropes. And it's on the ropes because we didn't take Teddy Roosevelt's advice very seriously. Way back in 1908, Teddy got wind of the fact that the state of Arizona was going to mine the Grand Canyon. So he went to the canyon, stood on the edge, looked out over its great vista, and he said, "Leave it as it is." And with those 5 words, he started the process of creating the Grand Canyon National Park. The problem today, though, is that leaving it as it is no longer an option in most of the country. There's only about 5% of the lower 48 states that's anything close to its original pristine ecological condition. That's because we've logged the country repeatedly, we've tilled it, we've drained it, we've grazed it. It's 770 million acres of rangeland, which is 4.5 times the size of Texas. And of course, we paved it or otherwise developed it. We have straightened our rivers and dammed them, and you can spell that any way you want. We have polluted our skies and changed our climate for centuries to come. We've drained our aquifers. We've introduced more than 3,300 species of plants from other continents, many of which are running amok in our natural areas, changing native plant communities. In short, we have carved up the natural world into tiny fragments of its former self. And each one of those fragments is too small and too isolated from other fragments to support the biodiversity, the species that run the ecosystems that support us. Why have we done this? Well, I guess we thought the Earth was so big, our nest was so big we could foul it forever and there wouldn't be any consequences. Of course, we were wrong about that, and that's why we're seeing headlines like this. The insect apocalypse is here. What does it mean for the rest of life on Earth? Talking about global insect decline. North America has lost 3 billion birds in the last 50 years. That's a third of the North American bird population gone. As a matter of fact, the UN now predicts that we're going to lose 1 million species to extinction, possibly within the next 20 years. And they predict this as if it's an option. It's not an option, folks. It is not an option. So I could go on talking about the pox that we humans have delivered upon the environment, thus upon all of our houses, but it's not what this talk is about. This talk is about a cure for that pox. It's a cure that will take small actions from a lot of people, but they'll deliver enormous physical, psychological, and environmental benefits to everybody. Let's return to this headline here, Insect Apocalypse is here. What does it mean for the rest of life on Earth? Well, the great E.O. Wilson from Harvard told us what it would mean if we were to lose our insects, and he did it way back in 1987. This paper, The Little Things That Run the World, his message was very clear. Life as we know it depends on insects. And if they were to disappear, so would most of our flowering plants, because we would have lost our pollinators, which would change not just the physical structure of terrestrial Earth, but it would drastically change energy flow through our terrestrial habitats. And the food webs that support our animals, our amphibians, our reptiles, our birds, and mammals would all collapse. So all those animals would disappear. The biosphere, the living portion of the Earth, would rot because we'd have lost insect decomposers that rapidly turn over nutrients, and all we would have is bacteria and fungi. And of course, humans would not survive any of those drastic changes. The good news is that that doesn't have to happen. We can save our insects, we can save our birds, we can save nature itself, but we're going to have to change the way we landscape to do that. Why is that? Well, probably don't need to remind you that we humans are products of nature. We're totally dependent on it. We're dependent on what we call ecosystem services. Here are just a few things that plants deliver for us and everything else. Ecosystem services aren't just for humans. Oxygen, pretty important. Clean water, also important. Carbon capture, enormously important in today's world. Plants are pulling carbon dioxide out of the atmosphere, locking it up in their tissues, and then pumping it into the ground. The extra carbon goes in the ground. Our soils are brown or black because of the carbon that plant roots have put in the ground. Plants are building topsoil, hold it in place, preventing floods, dampening severe weather, and many other things. What do animals do for plants? Well, they provide pest control services. They pollinate nearly 90% of our flowering plants, disperse plant seeds, and many other very important things. So designing landscapes like this that destroy the production of ecosystem services is simply not an option anymore. It never was a good option. But today, with 7.8, 7.9 billion people on the planet, it's not an option at all. We need more ecosystem services today than ever before. Now, there have been visionaries through the ages who recognized that we humans needed to work on our relationship with the Earth that supports us, and Aldo Leopold was one of the most eloquent. He wrote extensively at the beginning of the 1900s. One of the things he said was, the oldest task in human history is to live in a piece of land without spoiling it. Now, there have been some indigenous groups that are pretty good at doing that, but our huge Western societies and Asian societies have been terrible at doing that. We habitually take more from the Earth than it has to offer, totally spoiling an area, move to the next area, spoil that as well. Obviously not very sustainable. So Aldo had a dream. He had a dream that we could actually develop what he called a land ethic. And he wrote about this in the Sand County Almanac. In his dream, we would use the land the way we have to. We'd farm it and lumber it and graze and so on, but we would learn to do that gently without destroying local ecosystems. And if we did, that would be what he called the land ethic. What he never talked about, though, is developing a land ethic where we actually lived. And I'm not sure why he didn't, but I suspect that the notion that humans and nature cannot coexist in the same place at the same time was so deeply embedded in the culture of Aldo Leopold day, and it's still embedded in our own culture, that he might not have even seen it as an option. What I want to argue this afternoon is that living with nature not only is an option, it is now the only viable option that's left to us. You know, in the past, conservationists worked almost exclusively where there weren't a whole lot of people. We now have to turn that on its head, and we have to save nature, recreate it, really, where there are a lot of people, because that's most of the planet. Where are we going to start? Well, let's consider private property like this. 85% of the U.S. east of the Mississippi is privately owned. About 70-some% of the entire country is privately owned. If we don't do conservation on private property, we're going to fail, because that means we're focusing in areas that's just simply not enough land to preserve the amount of nature that we need to preserve. But there are a number of conservation opportunities that we need to start taking advantage of. And you know about some of them. Power and pipeline rights of ways, 21 million acres. We got 300,000 kilometers of power line cuts in the U.S. What a conservation opportunity for scrub habitat, for pollinator habitat. Railroad rights of ways, 3 million acres. Roadsides, 17 million acres. And we've got golf courses, 2 million acres. Airports, 3 million acres. You know, the Denver airport is twice the size of Manhattan. These are big areas. And then we have all the places where we live. We don't think of them as areas of conservation, but they could be. Hundreds of millions of acres in that land use. You add up just that, and you can think of other places. That's 599 million acres. How big is 599 million acres? Well, that's bigger than Vermont, plus New Jersey, plus Maine, Virginia, New York, Georgia, Florida, plus Oklahoma, plus Montana. Throw California in there, even Texas. Add up all those areas, still less than 599 million acres. So not having a place to do conservation is not the issue. We have lots of places we can do conservation. What we're really talking about here is reconstructing the natural world. Will it be exactly the way it was before we came and messed it up? No, it won't. But we can put together, we can reassemble specialized relationships, enough of them, so that you actually have functioning ecosystems again. But all species don't contribute equally to ecosystem function. So we have to start with the species that deliver the most, the ones that other species depend on. So yes, we're talking about pollinators that pollinate all those flowering plants that are running the ecosystems we had, the first trophic level. But we're also talking about the animals that deliver the energy that plants create. They capture the energy from the sun and turn it into food. But most animals, most vertebrates don't eat plants directly, they eat something that ate plants. And that something typically is insects, and most of those insects are caterpillars. So it turns out caterpillars are essential components of terrestrial ecosystems because they're delivering more energy from plants to other animals than any other type of plant eater. Imagine what would happen if we took caterpillars out of the system. Most of the energy would remain locked up in the plants. Let's use the Carolina chickadee as an example. Chickadees all over the country, different species are doing the same thing. During the winter, they are mostly seed eaters, but when it comes time to reproduce, they have to switch to insects. Their babies cannot eat seeds, and that's true for most insects. Can't eat seeds. And if they're in a healthy environment, they'll feed their young exclusively on caterpillars. And it turns out chickadees are not exceptions. 96% of our terrestrial birds are rearing their young on insects. And most of those insects are caterpillars. How do we know? Well, there's several lines of evidence that suggest that, but this one's pretty obvious. I had a PhD student recently who did a citizen science project. She put out a call to bird photographers to take pictures of birds during the breeding season when they were bringing prey items to the nest. And they sent thousands of pictures to her. Her name was Ashley Kennedy, sent them to Ashley. She identified the prey items in the beaks of the birds and reconstructed the nestling diets of 20 bird families, common bird families in North America. The green bars are the percentage of those nestling diets that were caterpillars. And in 16 out of the 20 bird families, caterpillars dominated the diet. So again, imagine what would happen if we took caterpillars out of the system. Most of our terrestrial birds would not be able to breed. Something special about caterpillars, what is it? A number of things. One is they're relatively soft prey items. So think of this guy as like a little sausage with a very thin wrapper. The wrapper is exoskeleton, it's cuticle, it's not digestible, so the birds don't want a lot of that. And if the prey item's soft, you can stuff it down the throat of your offspring without fear of injuring them. And if you've ever watched a parent bird rear its young, they're pretty rough. Their beak's like a plunger, they just stuff it down there. Caterpillars are also relatively large prey items. To a medium-sized caterpillar is equal to the biomass of 200 aphids. And some of our birds are chasing aphids, but you want to chase 200 aphids or get one caterpillar. They're nutritious, they're very high in fat, very high in protein, very low percentage of chitin compared to most other insects, particularly beetles. Beetles are not like little sausages, they're like little tanks. A lot of undigestible material there, and they also have lots of sharp edges. And it turns out that caterpillars are the best source of carotenoids for birds during the breeding season. I mention carotenoids not because I love organic chemistry, but because I'm a vertebrate, and you're a vertebrate, and birds are vertebrates, and vertebrates cannot make their own carotenoids. We have to get them from plants. And we have to get them from plants because they are essential components of a healthy vertebrate diet. What do carotenoids do for birds? Well, they stimulate the immune system. They're antioxidants, protect their DNA from oxidative damage. They improve color vision. You know, when your mother said, eat your carrots, you will see better, she was right. She didn't know she was right. It turns out she was right. Improve sperm vitality, improve sexual attractiveness. Now we're talking about things like this male prothonotary warbler. He's bright yellow because he's had access to lots of luteins. He makes pigments out of those luteins, puts them in his feathers, and the brighter yellow he is, the more ladies he attracts. So very important. Where are the birds getting their carotenoids from? They're getting them from the invertebrates that they eat, and during the breeding season, it's what they're feeding their young. But carotenoid content is not equal across bird prey atoms. The first two bars here are types of caterpillars, far more carotenoids in caterpillars than any other prey choice. Third bar is orthopteroids, things like crickets and grasshoppers and katydids. Here are the adult caterpillars down here, the moths and butterflies themselves, far fewer carotenoids because they're not eating green leaves. It's the caterpillars that eat the green leaves where the carotenoids are. And here's the earthworm way down here. So the early bird gets the worm, but he doesn't get any carotenoids when he gets the worm. Does this influence prey choice? Well, Ashley did another study with bluebirds. She put GoPro cameras on the roofs of bluebird houses, and those cameras took a picture once every second. The object was to get pictures of the bluebirds as they flew into the house with prey items, so we could see what they were actually bringing to the prey, to the birds, and then see how that related to the carotenoid content. She had a lot of bluebird houses and a lot of GoPro cameras, and she did it for 3 years. So she had over 1 million pictures to go through. But out of those pictures, she got 7,628 pictures good enough so she could identify the prey items. And you got a pretty good relationship here. Caterpillars brought back more than anything else, and they have the highest level of carotenoids, followed by those orthopteroids, and then everybody else is nestled down here in the corner. So it's really looking like caterpillars are not optional parts of bird diets. They seem to be essential parts of bird diets. So let's just say birds need caterpillars. Okay, how many do they need? Is 1 or 2 enough? Let's go back to chickadees. We've got a lot of data on chickadees. How many caterpillars does it take to make a clutch of chickadees? 1 or 2 is not enough. It takes many thousands, 6,000 to 9,000 caterpillars to make 1 clutch of chickadees, just to get them to the point where they fledge. And after they fledge, the parents continue to feed them another 21 days, and flying all around so nobody can count those caterpillars. But you're talking about many, many thousands of caterpillars. And if we want chickadees and other birds breeding in our human-dominated landscapes, we've got to have those caterpillars right there. These birds only forage about 50 meters from the nest. They're not flying 5 miles down the road to the nearest woodlot. And if we don't landscape in a way that supplies all of those insects, that's called insect decline. And it's really looking like that's highly related to bird decline. We went to the original data set from Rosenberg et al., the group that found that we had lost 3 billion birds in the last 50 years. And we divided those birds, these are terrestrial birds, into the species that rely on insects at some part of their life history and the species that do not require insects, are doves and finches that can reproduce on seeds. They actually gained a little bit of numbers over the last 50 years, but the birds that rely on insects, on average, lost 10 million individuals per species. Does improve cause and effect, but it certainly suggests there's a tight relationship there. So we need to landscape for a way that increases the amount of caterpillars, which is not the way we've been landscaping. We've been landscaping in ways that make sure that we have no insects at all, because everybody knows plants are just decorations and we don't want them to be eaten. We're going to change that culture if we can. We need to add landscapes or caterpillars to our landscapes by adding the plants that make them. Seems easy enough, but there is a catch, and that is that most plants don't make a lot of caterpillars because most caterpillars are really, really fussy about what they eat. And the monarch butterfly illustrates that perfectly. You can have your eucalyptus, you can have your boxwood and your crepe myrtle and any other non-native plant that you want, even lots of native plants, and the monarch's not going to eat it unless you have milkweeds. It's the only thing they're going to develop on. And they're not exceptions. That's called host plant specialization. And it turns out that most of the insects that eat plants are what we call host plant specialists. They can only eat particular plants. Why is that? Well, plants have forced them into that level of specialization. Plants don't want to be eaten. We want to capture the energy from the sun and use it for their own growth and reproduction. So they've loaded their leaves with nasty tasting chemicals, secondary metabolic compounds that make those leaves either bitter or downright toxic. And it's a really effective defense that keeps most of the insects of the world from eating most of the plants of the world. And that's why it's green out there. It's not because there are no insects out there that want to eat those plants. It's because most of the insects that are out there cannot eat most of the plants. But we do know that insects eat plants, so how do they do that? Well, this is where the specialization comes in. About 90% of the insects that eat plants can only eat particular plant lineages for which they have developed adaptations that allow them to get around, to circumvent those plant defenses. They develop enzymes that store and excrete and detoxify those nasty compounds, behavioral adaptations and life history adaptations that minimize their exposure to those compounds. But it takes a long period of evolutionary history with those particular plant lineages for all these adaptations to fall into place. And that's why our insects are so poor at eating non-native plants. And because all plant lineages protect themselves with different cocktail of chemical defenses, insects can't adapt to all of them, so they pick one or two and they get good at getting around one or two. That's the specialization we're talking about. So all I'm trying to say here is that if we're going to reconstruct functional food webs in places where we've dismantled them, we've got to choose the right plants. Plant choice matters. And I'm going to give you 3 examples of how well this works. It can work anywhere. We're talking about private property here, personal, your yards, but it certainly can work in power lines or any other type of landscape. This is where I live with my wife, Cindy. I'm sitting in that window right now. We have 10 acres in Oxford, Pennsylvania. It was a small farm that was broken up some years ago. It was exhausted. It had been farmed for 300 years. And the last bit of farming they did was mowing for hay, but really just mowing the rootstocks of all the Asian invasive species. So what we had to do was get rid of all those invasive species when we moved in and then start putting in the plants that we wanted. And I was selfish about which plants I chose because I wanted to attract as many caterpillar species as I could to our yard because they are the basis of the food web. One of the first things I tried to do is get Canadian owlets. I'd never seen a Canadian owlet. That's what the adult looks like. But to have Canadian owlets, you have to have meadow rue. That's its only host plant. It's a specialist on meadow rue. We didn't have any meadow rue because our native flora was decimated centuries ago. So I got some meadow rue seeds from someplace, planted them. They grew very well, but I didn't know how long it would take, if ever, for the Canadian owlets to find my meadow rue. So I didn't go out and check it right away. But after about a month and a half, I did go out and check it, and it was almost defoliated by Canadian owlets. They had found it right away. No idea where they came from, but very successful. Now a good population of both meadow rue and Canadian owlets. So I've added 2 species to the property. Same story with the goldenrod stowaway. This is a misnomer. This beautiful moth has nothing to do with goldenrod. It's actually a specialist on this plant, ditch daisy, Bidens aristosa. I did know where there was some ditch daisy about 14 miles away in a power line cut. See, so that was a good habitat there. I got some seeds and planted them in our house. They grew very nicely. Took about a year for the moth to actually find my Bidens, but it did, and now we've got a good population of both. So we've added 4 species. Wanted hackberry emperor because it's a butterfly that ought to be at our house, but as the name implies, it is a specialist on hackberry. We didn't have any hackberry, so I planted hackberry. It took about 4 years for the butterflies to find it, but they finally did. I walked by one of my hackberry trees, and just one branch in June this year, there were 9 hackberry emperor butterflies on that single branch. I did not plant goldenrod, came in on its own, and along with it, many of the specialists that eat goldenrod, like the beautiful brown-hooded owlet, the Arsidra flower moth, the goldenrod leaf miner, the distinct sparaginothus, goldenrod gall moth. This is what I'm waiting for. This is the goldenrod flower moth. I don't know why it hasn't found our goldenrod yet, but it hasn't. So this is that's what the larvae look like. This is anticipation. It's like waiting for the ketchup to come out of the bottle. Every year I go out and I look for the goldenrod flower moth, and one of these years I'm going to find it. That'll be a great day. Planted Virginia creeper. It's a great native plant, nice fall color. Climbs our trees, but it doesn't pull them down. It's a wonderful host for a number of our sphinx moths, things like the beautiful Pandora sphinx and its beautiful, equally beautiful adult, the lettered sphinx, the hog sphinx, the abbot sphinx, and many other types of caterpillars on Virginia creeper. I wanted the zebra swallowtail. I think it's our prettiest swallowtail, but I was pushing it here because we're at the northern limit. The closest population I know of is 26 miles south of us. These guys are pawpaw specialists. There was no pawpaw at our house, so I planted pawpaw. We waited 9 years, but they finally found it. In the meantime, we got the pawpaw sphinx. I didn't know there was a pawpaw sphinx. And of course, lots of pawpaws. Wanted the double-toothed prominent because it's just a very cool looking caterpillar, but it's a specialist on elm, so I planted American elm. Caterpillar came right away. Wanted the evening primrose moth because it's beautiful. I like beauty like anybody else. So we planted evening primrose. The moth came, spends the day with its head stuffed in the flowers. It's very cute. And I planted lots of oaks. Now, these are just examples of what we've added to our property, but I want to focus on oaks for a while because they are so important. This is the Bedford oak in Bedford, New York, and it's enormous. And people argue about whether it's 300 years old or 400 years old. And, you know, that's an issue for a lot of people. People say, I don't want to plant an oak because I won't live long enough to enjoy it. Well, unless you die the very next year, you can enjoy it because these oaks, no matter how small they are, contribute right away. And I know that for a fact because most of the oaks I put on our property, I planted as acorns, which meant they were free, or 2-foot bare root whips for about $1.50 each. And right away, they started to attract the drivers of my local food web. Things like the solitary oak leaf miner, Juvenil's dusky wing, the yellow-shouldered moth, the orange-headed epicalema, the red-washed caterpillar, the yellow-vested moth, orange-tufted oneida, the spiny oak caterpillar, the two-spotted oak punky, the variable oak leaf caterpillar, the red-humped oakworm, the orange-humped oakworm, the pink-striped oakworm, the delightful dagger moth, the pleasant dagger moth, the lesser oak dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the crown bucolatrix, the white blotch heterocampa, the oblique heterocampa, the red-line panapoda, the laugher, and literally hundreds more species of moths only have come to my oaks. And they come right away. This is a pin oak that has just popped up above the leaf surfer, and here's a crocus geometer standing on the forest floor eating those oak leaves. So your oaks start to contribute right away. You don't have to wait centuries. This is a picture from our house as it looks today. I'm still sitting in this window up here. We're very traditional. We've got lawn here, but I just want to emphasize we put plants back. And I'm still adding plants. I'm sure all the ones that used to be here aren't here yet, but every time I do, I find new species of moths that have come to our property. And 4 years ago, I made a goal of taking photographs of every species of moth that I could find on our property. And I am up to 1,030 species of moths right on our little old 10 acres. Now, we do have 10 acres. Pennsylvania is 2.4 million acres. So on 1/240,000th of the land area, we've got 38% of all the moth species that occur in Pennsylvania. And because each one of those is a type of bird food, we've recorded 59 species of terrestrial birds that have bred on our 10 acres, which is 40% of all the terrestrial birds that breed in Pennsylvania. So this works. And we need positive feedback like that because we keep seeing headlines like this. 2/3 of the Earth's wildlife have vanished since 1970. I'm thinking, not at our house. I'm sure we have increased biodiversity by more than 2/3 by simply putting the right plants back. We can reverse these horrible headlines. But I know what you're thinking. We've got 10 acres and maybe you don't. And will it work on smaller properties? And that's a good question. Let's go to Margie and Dan Terpster's house in Kirkwood, Missouri, and see. They have 0.6 acres, 18 times less land than Cindy and I have, and they live right in the middle of suburbia, surrounded by the neighbors with the big lawns. Their primary invasive species was bush honeysuckle, so the first thing they did was get rid of their bush honeysuckle. They planted a lot of native plants and put in a water feature they call a bubbler, and then they sat back and started to count their birds. They're up to 149 bird species that have used their property, 35 warbler species. Just to put that in perspective, on our 10 acres, we've only recorded 8 warbler species at our house. So yes, it works on smaller properties. What about urban yards? Let's go to Pam Carlson's house in Chicago. And I mean in Chicago. One of the red waves O'Hare Airport is right over that wall right there. Kennedy Expressway is over here, and she only has 1/10 of an acre. That's 3 times smaller than the average lot size in North America. Well, Pam did the same thing. She got rid of her invasive plants, put in 60 species of native plants, a water feature for her birds, and then she sat back and started to count her bird species. And she's up to 100, actually it's 117 species of birds. A great horned owl came the other day. I've used her yard, including a woodcock. If you haven't seen a woodcock lately, there it is. There's Pam's woodcock. You can go to her house in Chicago and check it out. What about city centers, though? 82% of us live in cities. Well, in 2014, I was staring at this plant, Asclepias tuberosa. People call it butterfly weed. But that reminds me that we have a marketing issue with our native plants. We call them weeds and wonder why people don't plant them. So we're not going to call this butterfly weed anymore. We're going to call it Monarch's Delight. All right, I was staring at Monarch's Delight, and the first thing I saw were 2 species of leafcutter bees, megachilid bees. I know they're leafcutter bees because they collect their pollen on their tummy, not on their legs. Well, they have very specific requirements, or they can't be in an area. They need pollen and they need nectar, but they also need soft leaves, leaves like you would find on redbud, because they cut the edges out of those leaves and leave these little semicircles. Then they roll them up into tubes, snip them to glue them together there with silk, and then stuff them full of pollen, and that's where they lay their eggs. So here's 3 larvae developing in a tube-like structure, which they put into a crack or a crevice. Well, there was a redbud plant growing right next to the Monarch's Delight, and that's why those bees were there. They had everything they needed. And it's why bumblebees were there as well. Remember, queen bumblebees overwinter alone. Their colony, all their workers die. So in the spring, they've got to do all the work by themselves. So they need lots of abundant forage, or their colony fails right away. Well, the redbud was there, blooms very early. It's exactly what those bumblebees needed. And then I saw a monarch. Actually, I saw 2 monarchs on Monarch's Delight. Now, this was 2014. 2013 was the low point for the monarch population east of the Rockies. And I had gone all of 2013 without seeing a single monarch. So here it was. This was June 2014. Here are 2 monarchs. I was very encouraged. Maybe the monarchs weren't going to disappear. Why were they there? Well, they had Monarch's Delight. They also had another species of milkweed there. I think it's purple milkweed. They had forage, but they also had their host plant. They could reproduce. Do you know where I was? I was on the High Line in the middle of Manhattan, 30 feet above the taxis and the cement, right in the middle of construction. The High Line, if you're not familiar with it, is an elevated railroad that had been abandoned for years. Somebody went up and saw a whole bunch of native plants had seeded in all by themselves. So they decided to turn it into a tourist destination. And now it is a major tourist destination. More than 1 million people go to the High Line every year. And here they are walking back and forth. And this is the strip of nature. It's a strip that follows the railroad about a mile. And there's the Monarch's Delight. It's, we're not talking about a huge area here. Somebody just did a study for the bees of the High Line. There are 30 species that have found it in the middle of Manhattan. So this is really encouraging to me. I figured if I went and saw the plants in the High Line, they'd be pretty plants, but nothing would be on them. But I was completely wrong. Which told me if thoughtful native plantings can bring life back to the middle of Manhattan, we can do this anywhere. There are 4 things we need to think about, though. I call them keys to success if we're going to succeed. And one of them is we've got to shrink the area that's in lawn in the U.S. Now, I know there's a lot of Californians that are not guilty of this, but we in the East certainly are. We've got more than 40 million acres of lawn nationwide, which is the size of New England. And it's a deadscape. It's a status symbol. I understand why we need status symbols, but let's cut that area in half. We're still going to maintain the area of lawn we keep. We'll be good citizens. We'll fit in with the culture, but let's cut it in half. And if we do that, that's another 20 million acres we can use for conservation. And we can do that conservation right at home. So we can create a new national park, call it Homegrown National Park, and it'll be bigger than the Adirondacks, plus Yellowstone, Yosemite, Grand Tetons, Canyonlands, Mount Rainier, North Cascades, Badlands National Park, Olympic National Park, Sequoia National Park, the Grand Canyon, Denali, which is huge, even the Great Smoky Mountains. You add up all those parks, still less than 20 million acres. So we would have the largest national park in the country. And there are a number of benefits that we will be able to enjoy if we put some part of nature right where we live. And one of the major ones is we get to create or recreate, in case we had one as a child, a personal relationship with the natural world. And we get to do it at our own time and our own pace. We can avoid crowds. If you go to a real national park, millions of people there. It's free. Nobody's going to charge you. It's never closed, no matter what pandemic comes down the road. No travel hassles. You get to experience the natural world alone. And this is really important, particularly for our kids. Our kids, Richard Liu says our kids are suffering from nature deficit disorder. So we're doing the best we can. We get 30 kids, put them on a bus with a teacher, and they drive for an hour, and then they walk around a natural area. Teacher tells them not to touch anything, and then they get back in the bus and drive home. And I guess that's better than nothing. But what they've really experienced is 30 other kids and a teacher telling them not to touch anything. If there's nature right where they live, let them go outside all by themselves, no parental supervision. Let them figure it out by their own. I think there's an excellent chance that they'll survive. And they might even learn how to hunt lizards. I'm learning this from my own granddaughter. This is Zoe, who lives in Hawaii, and her patch of nature is very small. It's a little piece of grass with a hedge, maybe 10 by 10 feet of grass. But she has discovered there are anoa lizards there. And this is how you hunt lizards, she tells me. You get on the ground and you disguise yourself with leaves and sticks so that the lizards can't see you coming. And you crawl very slowly towards the lizards. No smiling. This is serious business. You can wear your best dress, that's okay. But you sneak up on the lizard, you catch the lizard, you put it in an aquarium, and there's your personal relationship. I don't think Zoe is going to be catching lizards on the ground for the rest of her life, but I guarantee she will remember catching lizards. There's her personal relationship with nature, and now she knows this is important. She will be a good steward of the planet when she grows up. If you want to know other things to do other than hunt lizards, get Nature Play at Home by Nancy Stranisti. A number of wonderful examples right in that book. And if you want to join Homegrown National Park, we've created a new website called homegrownnationalpark.org. And this map is in there. You can actually put in your data of where you are changing the environment, putting in those powerful native plants. And it will light up. We're going to get to see the whole nation join this effort here. We can see connectivity happen. It's going to be a fun social media activity. The object is to get beyond the choir here so that people who aren't thinking about this will actually start thinking about it. All right, we're going to shrink the lawn. What plants are we going to put in the area that is now lawn, or the half that we take out? Well, some of them have to be what I call keystone plants. Now remember what a keystone is. Picture a Roman arch. The keystone is the stone in the center of that arch. And if you take that stone out, the arch collapses. Same thing with keystone plants. If you take them out of a food web, it collapses. Why is that? Because a keystone plant is making most of the food in your food web. There's only about 5% of our native plants are making 75% of the caterpillar food that drives our food webs. 14% of our native plants are making 90% of the caterpillar food, which means there's a lot of native plants that are there, but they're not doing a whole lot. So, just when you build a house, you build a house out of 2x4s. You don't build it out of wallpaper. You can't leave the 2x4s out. And therefore, they are essential. The question is no longer simply, are natives better than non-natives? On average, they certainly are. But it's really, do we want ecologically productive plants? Some natives just aren't that productive in our landscapes. Or ecologically destructive plants, those Asian ornamentals that escape and become serious invasive species, biological pollution, and ecologically castrate our local landscapes. I get an email once or twice a year from somebody saying, don't I know that ginkgo biloba, ginkgo from Asia, actually grew in North America 7 million years ago? That makes them native, so we can plant them and everything will be great. Yes, I do know that the ginkgos grew in North America 7 million years ago. We can argue about whether that makes them native today, but I'm not going to bother because that is not our metric anymore. The metric is, what are they contributing to our local food web? I don't care if ginkgos grew on the moon 7 million years ago. They produce zero species of caterpillars. So they're there, they're occupying space, but they're not contributing to local food webs. What is? Well, in 84% of the counties in North America, oaks, the genus Quercus, are the top keystone plants. In the mid-Atlantic states, they support 557 species of bird food, over 900 species nationwide. You have many more species in California, species of oaks in California, and they are definitely keystone plants there. There's no other plant genus that comes close to that. Here's the power of keystone oaks in my yard. Remember, I've taken pictures of 1,030 moss species so far. Haven't gotten to the butterflies yet. Out of the 1,030 species, 906 have known host plants. So there's over 100 I don't know what they're eating. Of the 906, 267 species use oaks. And we've got 67 genera of native plants, native woody plants on our property, and only one of them is the genus Quercus. And we got hundreds of genera of herbaceous plants. So oaks represent less than 1.5% of our woody plant diversity and way less than 1% of our total plant diversity, but they're supporting almost 30% of our moss species diversity. So imagine what would happen to the biodiversity on our property if we took oaks away. Where do you find out what your keystone plants are? Well, in California, CalScape is the best tool. It's a wonderful tool. All of the native plants in California are geo-referenced. You know exactly where they occur. You can look at where you live and see what the native plants are. And then they have a mechanism for telling which ones are the most productive. If you live elsewhere, go to the Native Plant Finder, National Wildlife Federation, put in your zip code, and the ranked list of the most productive plants will pop up for your county, both woody and herbaceous plants. Okay, we're going to shrink the lawn. We're going to add keystone plants, bring lots of insects to our yard, and then we're going to kill them with our security light at night. And of course, that is not the goal. There's a lot of research, particularly from Europe, which is suggesting that light pollution is one of the major causes of insect declines, particularly in the temperate zone. And these are all the ways that lights kill insects. We don't have time to go into it, but this is actually good news to me, because if this is a major cause of insect declines, it's one of the easiest things to reverse. All we have to do is turn our lights out, flick of a switch. But I know what you're going to say. I can't turn my lights out because the bad man will come. Okay, put a motion sensor on your security light, and then it'll only turn on when the bad man does come. And the first thing you're going to find out is the bad man doesn't come very often. If you don't want to do that, take the white bulb, the white light out of your security light and put in a yellow bulb. And yellow LED bulb is the best. It's the least attractive to local insects. If we all switched out our night lights with yellow LED bulbs, not only would we save billions of insects during the summer, we would also save billions of dollars of energy. All right, we're going to shrink the lawn. We're going to call these insects in. We're going to turn our lights out, and then we're going to get Mosquito Joe to come and spray and kill everything. I mean, we're just real good at killing all the insects around us. You know, again, I don't have time to go into this, but this is not the way you control adult mosquitoes or mosquitoes. You control mosquitoes in the larval stage. You have to kill 90% of the mosquitoes with your fogging to get good control, and fogging has been shown to only kill about 10%. So it's expensive and it doesn't work. Mosquito dunks work. Get a bucket, fill it full of water, put some straw or hay in there, and let it ferment for a couple of days, and it becomes an irresistible place for mosquitoes to lay their eggs. Then you put in a mosquito dunk, Bacillus thuringiensis in there, the larvae feed on it, and they die. It's a very targeted control of mosquitoes in the larval stage. Very effective. Okay, the last thing we need to do is to landscape in ways that allow caterpillars to complete their development. What do I mean by that? Well, I live in Chester County, Pennsylvania, where there are 511 species of caterpillars that develop on oaks. A few of them complete their development on the tree itself, like the polyphemus moth. It eats the leaves, then it spins a cocoon and hangs from the tree, and then the adult emerges and it does it all again. I wish everything did that, but most species don't. 480 species, 94% of them drop from the tree, wiggle beneath the ground and pupate underground, or they spin a cocoon in the leaf litter under the tree. And the problem is we don't have any leaf litter under the tree, and we mow our ground and compact it to the point where our caterpillars can't get under there to pupate. So this becomes an ecological trap, and very shortly you wipe out the insects that are here. I'm convinced that this type of landscaping, which is everywhere, is one of the major causes of insect decline. And of course, the cement landscape in our cities is even less inviting, less of a viable option for our moths. And I'm not trying to discourage the use of trees in cities. I'm trying to discourage the use of the profligate use of cement as a default landscape. We know this is a bad idea. It's just laziness, and it ruins our watersheds. This is what most people do. You put a tree in the big lawn. Nobody's measured how well the caterpillars survive in a situation like this, but I guarantee they survive better in a situation like this, where you have a tree and then a layered landscape. A shrub, this is a native azalea and ferns and ground cover. Caterpillar drops down, can easily get underground, spin its cocoon. It's a safe site. Nobody's going to walk there and squish it. This is where you can do your spring ephemeral gardening. This is the way you shrink your lawn. You put beds around your trees. They're safe sites for your caterpillars, and you have less area in lawn. And this is where you use ground covers, things like yerba buena, a good one in California, safe sites for your caterpillars. More good news. There is room for compromise in our plant choices here. And this comes from another of my students, Desiree Narango, she's graduated at this point, but she studied the sustainability of chickadee populations in the suburbs of Washington, D.C., inside the Washington Beltway. She compared landscapes that were largely native with landscapes that were largely introduced plants. And the first thing she found is that the landscapes dominated by non-natives produced 75% fewer caterpillars. So right away, you've reduced the bird food by 75%. They were 60% less likely to have breeding chickadees at all. So even though there's a nest box up, the chickadees would come and look around and say, there's not enough food here, we're not even going to try. If they did try, their nests contained 1.5 fewer eggs. Those clutches were 29% less likely to survive. If they did survive, they produced 1.2 fewer fledglings, and it took them 1.5 days longer to do that. If you put all that together in a population growth model, this is what you get as a function of the percentage of non-native woody plant biomass in your landscape. The dotted line is replacement rate. That is the rate at which the population has to make babies to replace the adults that die every year. And if you reproduce at that rate, you've got a sustainable population. It's not growing, but it's not shrinking either. If you reproduce down here, I don't know if you can see my pointer or not. If you're making more babies than adults die, then you have a growing population. But if you're under the dotted line, you're making fewer babies than adults die. You have a shrinking, unsustainable population. Those lines intersect right around where you've got 30% non-native woody plant biomass in your yard. So as long as your yard is at least 70% native, you can have a sustainable breeding population of birds. The good news is that gives us 30% of our woody plant biomass for compromise. As long as we're not planting invasive plants, you can have your crepe myrtle or whatever non-native you want, as long as it's not dominating the landscape. And that's good news to me, because we love our non-native ornamentals. And if my message was you can't have any, very few people would listen. It's not the presence of non-native plants that destroys local food webs. It is the absence of native plants. So we get those native plants in there, we'll be all right. Can we get a pollinator garden into a traditional suburban yard like this? Of course we can. Just put a little fence around it. This formalizes it. This tells people it's intentional. It's not a bunch of weeds. And we want to do this, of course, for pollinators everywhere, not just next to agriculture, because pollinators pollinate 80% of all plants and 90% of all flowering plants. We need them everywhere. How about this? It's a bigger space. It's formalized. Compare the amount of life that's in that garden with the amount of life on the lawn next to it. Good motivation. Can municipalities help us live with nature? Of course they can. And more municipalities are doing that. The state of Minnesota has a cost-sharing program to encourage homeowners to remove part or all of their lawn and replace it with traditional Minnesota prairie plants. They're paying you to do that. Florida, there's an island of Florida that's paying residents to allow burrowing owls, listed species, to burrow in their front yard. This is the way the Endangered Species Act should have been written, with carrots rather than sticks. If you have an endangered species on your property, they're going to pay you to take care of it, as opposed to fining you because you do something with your property. Missouri and Fayetteville, Arkansas have a bounty on calorie pears, one of the most invasive ornamentals that we can plant. If you document you've taken out a calorie pear, they'll give you a free tree replacement. And water utilities, San Antonio Water System is giving people $100 coupons to get rid of their non-native thirsty plants and putting in water-efficient natives. Buffalo's doing that as not a water issue. They just want to get more natives into the landscape. And of course, you've got your grass replacement programs in California and Arizona, up to $2 per square foot rebate by putting in appropriate xeric plants. Okay, I think we've made 3 missteps in the early years of conservation. And the first is that we've assumed nature is important, but not essential. We like it. We can watch it on television, but it's not essential. And that means when push comes to shove, when resources are short, which is always, nature takes a back seat. I went to the Cincinnati Zoo before the virus broke out, and there was this wall-sized poster there to save wildlife for future generations. And this, of course, has been the argument since Teddy Roosevelt. We want to create our national parks so that future generations can appreciate them. And I get that, but that suggests that nature is around just for entertainment. It is far more important than that. We need to save the natural world so that we have future generations, because we're not going to do well on this planet without it. We've also assumed that humans and nature cannot coexist. We talked about this, but that restricts conservation to just the small areas that are relatively untouched by humans. And that condemns them to failure, because those areas are too small and too isolated from each other to sustain the species that we need. David Quammen has an excellent analogy between a Persian rug and an ecosystem. This is a functional Persian rug. That is not 71 Persian rugs. That is 71 rug fragments, none of which are acting like a Persian rug. And that, of course, is what we've done to our ecosystems. The UN designates biosphere reserves as places of ecological significance. And I hate that language because it suggests there are places on planet Earth with no ecological significance. Not so. Every square inch of the planet has ecological significance, including our yards, including our power line cuts, including all of our infrastructure. So what we need to do is put the plants back. We need to glue our rug back together again, stitch our ecosystems back together again, and not just by making biological corridors where plants and animals can move back and forth between viable habitat. We need to make viable habitat where we humans are. We have to start sharing our human-dominated spaces with the natural world. Our third misstep is to leave Earth stewardship to just a few specialists, a few ecologists, a few conservation biologists. We didn't see it as an inherent responsibility of every human being on the planet. And I have no idea why, because every person on the planet depends entirely on the quality of Earth's ecosystems. So why wouldn't everybody have, bear the responsibility for good Earth stewardship? Stan Rushworth, a Cherokee elder, once said that the Western settler mindset was, I have rights. The mindset of indigenous people is, I have obligations. You were not born with those mindsets, you're taught them. We've been very good at teaching the I have rights part, but really poor at teaching our obligations towards planet Earth. We've got to get better at that. It doesn't mean that we have to save biodiversity for a living, but we really can save it where we live. And if we do, that empowers each one of us. You know, it's easy to feel powerless these days. You can't make a difference. But in this case, the cliche really works. Go out and plant that oak tree. Plant any of the keystone plants. Put in your pollinator garden. Shrink your lawn. Get rid of your invasive species. One person can do all of those things on the piece of the earth that they own or can volunteer on. That makes you an important cog in the future wheel of conservation, and it shrinks the problem down to something that's manageable. Don't worry about the entire planet's issues. You'll go crazy doing that. Just worry about the piece of the earth that you can influence. So as property owners or as volunteers, each one of us has the power, and we certainly have the responsibility to fix dead landscapes like this. Whether or not we decide to do so is going to determine nature's fate and ultimately our own fate. And I convinced my grandchildren that you are nature's best hope. I hope I've convinced you as well. Thanks very much.
Okay, Doug, thank you so much for joining us today and doing an exclusive interview with me. We just listened to your lecture. Do you have a particular experience or event that occurred in your life that kind of affirmed your direction and commitment to working on ecology and thinking about the protection of our ecosystems?
I was born loving the natural world. You know, this is not something I learned about. I got a brother and a sister. They were raised in the same house, and they're not into that. So it just was in my genes. So I was attracted to it right away. And if there was a single event, I would point to third grade. We had moved into our new house. It was the first house built on a circle, and they built the new houses from left to right. So the lot next to us was the last lot to be developed. There was a little pond on that lot. And I used to go over there in the spring. The toads were singing, and I'd never heard that before. And then they laid eggs, and all the pollywogs were swimming around. And so, that was my my close interaction with nature in third grade. And I was there, hunkered down, when the little guys started to hop out onto the ground. Metamorphosis was complete. It was so exciting. And a bulldozer came and buried the whole thing. I don't think the bulldozer guy even saw me sitting there. But that, right then I said, there are too many people in the world. So I certainly remembered that, but it didn't set a career path or anything. I was in third grade. I didn't know what I was going to do. And then I did end up as an entomologist. I was a bio major. I didn't know what to do with the bio major. I decided I would not go into teaching because I was too afraid to talk in front of people. So
I think that's changed.
yeah, you get used to it. So yeah, I did a brief stint in dental school and realized I don't want to be a dentist. So I went to graduate school in entomology and got a PhD in entomology. But then I studied insect behavior, behavioral ecology for so I got my degree in '81, and it wasn't until the year 2000 that we moved into our new house in Pennsylvania, which was built on a farm that was broken up, and it was just this giant tangle of Asian vines. It was all invasive species. I call it Sleeping Beauty's castle. You couldn't walk anywhere for all the multiflora rose and Oriental bittersweet and everything. So that experience tuned me into the really the growing problems that we have from switching out the native plants that support our ecosystems and replacing them with non-native plants, not just as invasives, but as the ornamentals in our yards. And I started getting all the statistics together, and the magnitude of the problem became very clear. So I'd done a lot of interesting things. I mean, David Attenborough came and filmed in our lab. It was all great, but nobody cared about any of it. And I get that. They're just interesting, but they weren't going to change the world. This was the first thing I'd ever done that I think really is important, and the public liked it. I mean, the public said, this is important. We need to know about this. So since 2000, when I started working on this, that's when I started to write the book and do the research and get the data. The final years of my career were very clear. This is a serious problem that we have to focus on, and I won't be changing directions for sure.
Wow. So leading up, so you had a good run of several decades of work and research and establishing your career and your job. And then you kind of hit upon, this is what I got to focus on to kind of round this out and make sure all of this work has a big impact.
Yeah, and of course, at that point, I was a full professor. I could spend a lot of time talking to the public. That's not the way you get tenure. It's not the way you make friends at the university. But it didn't matter for me, so I spent a lot of time doing that. And I get it that young academicians don't have the freedom to do that. We were still doing research. We're still publishing in good journals, but enormous amount of time bringing this message to the people who are going to make the difference, the people who own planet Earth. It's private landowners. This is, we've got a global biodiversity crisis, but it's going to be a grassroots solution. People who own little plots of the planet all over the planet are going to make the difference. And those are the people I'm talking to because they don't have a clue that their little piece of the earth actually is important in the future of conservation.
And it gets to this point about that we all have sort of a role to play, even if you don't own property. Actually, I mean, let's just say you live in an apartment and you have a patio. You can put plants out, and you can put a bird feeder out and a bird bath out, or whatever that. You can do something. I'm a conservation biologist and been doing this for a while, 25 years or so. And I've read a lot of books about a lot of popular, published books that are not in the peer-reviewed literature about nature and preserving nature and all of that. And I just got curious about why Nature's Best Hope and this book, of all of the ones out there, is capturing so much attention and has such a good uptake from a broad audience. And I was wondering a little bit about what your thoughts are on that.
Well, I think partially it's timing. Along with Nature's Best Hope has come a lot of very scary statistics. The insect apocalypse is here, and we've lost 3 billion birds, and the UN says 1 million species are going to go extinct. To my surprise, but also my delight, this has upset the public. They've listened to this. I didn't think anybody would care about the fact that we're losing insects, but I got emails right away. What can we do? What can we do? Well, the message in Nature's Best Hope is you can do something. The message is that it empowers you. I talk about 4 things that everybody can do if you own any property. You can shrink the area you have in lawn. You can put in a pollinator garden. You can use keystone plants. You can get rid of your invasive species. One person can do that. One person can revitalize their local ecosystem in doing that. And that empowers people. And they love that, because now they're just not sitting there watching the earth go down the tubes. They're participating. And I think that's the difference. An awful lot of the other books, they're gloom and doom. Things are terrible and they're getting worse. And there you go.
Yeah.
People want to do something about it, and there are things they can do about it. So.
And we don't want to read books that when we close the book, we're super depressed.
Exactly.
Right.
Yeah.
And yeah. One thing I noticed too in the book is that scientists are trained to be very careful on their observations and to look for evidence. And then when you get to the point in that peer-reviewed paper of describing your conclusions, you have to be pretty careful, right? What did I really prove? What did I not prove? And so I think that we tend to sort of waffle on our answers. And it's part of our training is that you can ask somebody a straight question, what should I do about, pesticides or this pollutant going in this water? And the scientist will give you a super protracted answer, take them 2 hours, and you still don't know what they said, right?
Yeah.
And here's what I noticed in yours. So here's something that I thought was pretty neat in your book is at the end of it, there's frequently asked questions. And I'll just give a couple of examples. Here's a question. What about the risks of bringing nature into our everyday space? Isn't interacting with nature dangerous? We get this question all the time. If you attract pollinators to your yard or your property, you're going to get stung by a bee. And then what are we going to do if we get stung by a bee, right? So your answer to this question was, so I'm thinking through, okay, what is my answer to this question about nature being dangerous? Your answer is, a 2006-2010 government study reported that there's 88,000 deaths from alcohol every year in this country. Yet one physician called West Nile virus, which killed 105 people nationwide, a matter of life and death. So you cut through sort of the, isn't this super dangerous? Well, let's put this kind of in perspective a little bit, right? If we're going to get sort of, asking these questions. So here's another example. Could you send me a list of non-toxic plants for kids? So worried about kids, right, going into their backyard and stuffing up plants and vegetation in their mouth and getting sick. Okay, your answer. And so I read the question, I'm already developing my answer, right? The chemical composition of vegetation and plants and what would you do and when do you take the kid to the doctor? Your answer is, the ironic thing is that kids don't eat plants. Even the vegetables that we want them to eat. They're not like horses. The first taste of a leaf is bitter, and they won't take another bite. That's
True.
a funny answer, and it's true, right?
It is true.
Yeah. So
Yeah.
I wonder if that's part of, just like, you're a trained scientist. You have your own Wikipedia page. You're very impressive on the scientific front, right? But in here, you're kind of, it seems to me, in this stage of your career, you're transitioning into this phenomenally effective communicator.
Well,
Right?
thank you. That's, I think it's accidental, but I've talked to audiences a lot. I hear the questions they ask. I see what they understand, and I see what they don't understand. You're right about scientists. They're trying to cover every base. And the first thing we scientists go to is the exceptions, because exceptions are interesting. Why are they exceptions? But if that's all you talk about with the public, they think that's the general rule. There's still exceptions. What I do is focus on the general rule and hope that they get that. There are exceptions to almost everything I say, and people are quick to point them out, but I don't want them to lose the general rule. So, has a child ever been poisoned by a plant eating in the back? Probably. We could find it someplace, but the general rule is they don't eat plants, and your cell phone is likely to kill your child much faster than anything in their backyard.
So what is Homegrown National Park? What are your intentions with it? And should I do that even though my backyard is already certified as a habitat?
Okay, yeah. Well, quickly, Homegrown, I came up with the idea many years ago when I was looking at the statistics for the amount of area we have in lawn, which is in 2005, it was 40 million acres, which is the size of New England. So I said, well, what would happen if we cut that area in half? Well, that gives us 20 million acres to put towards conservation. How big is that? So I started adding up the area of our major national parks. I filled up a page, including Denali and Yosemite and Yellowstone and all of those big guys, and it was still less than 20 million acres. So I said, gee whiz, and if we do this at home, we'll call it Homegrown National Park. It'll be the biggest park in the country.
What would you say to the struggling ecologist who is wondering if they are making a difference in their career and if they can make a difference? And I'll tell you, I'm asking this question a little bit on behalf of my dad, who said I would never get a job as a biologist, and told me I needed to go and be a dentist. That was my sure path career. So I'm struggling right here a little bit. Am I making a difference? What should we be doing?
How many people is the Pollinator Party going to reach?
We're trying to reach 1.5 million. Yeah, in a
Is
week.
that going to make a difference? I think so. You would not have 1.5 million dentists. I think going into ecology, particularly the restoration side of it, conservation side of it, has never been more important. I talk about restoration rather than conservation because there's very little left to conserve. We need to restore what we've wrecked because we've wrecked most of the planet at this point. It is restorable. It won't be exactly the way it was, but we can reunite the specialized interactions that make ecosystems work, and we can do it almost anywhere. And I know that because I've seen it happen right at my own house. I've seen it happen in lots of places. It's going to take a lot of people to do that. It's going to take a lot of knowledge to do that. There's an entire vacant niche in terms, I call it ecological landscaping. I go in and give a talk someplace and people say, who can I hire? And I say, no idea. We need ecologists to fill those niches, to go around the country and put it back together again. So I think this is a great time to go to get some ecological training.
Yeah. Okay, great. And I think that I think that you are a really good example too of for scientists to also remember that part of the job and to be thinking about how we communicate in a way that other people understand. And not everybody's a great communicator. I'm naturally an introvert. You seem like you're probably naturally an introvert, but we sort of have some you're not?
Well, I am an introvert,
Yeah.
not an extrovert. You might have meant to say extrovert, but
Yeah, no, I can see you're an introvert. So, but I think we generally have a responsibility to manage that for ourselves so that we can communicate and we can communicate well. Because we may know lots and lots of things in our head or in our scientific papers, but if we cannot translate it into something that other people can absorb and assimilate and apply in their lives, then that will very quickly curtail the impact of our work.
yes, and science has suffered terribly from that. And climate change is a perfect example of how we have suffered from that. And I understand how that happens. When you're hired in academia, you're hired for the quality of your research and how much money you bring in, not for your ability to talk to anybody. So now we've come a long way since when I was looking for a job, because then it was actually frowned upon. It's a waste of time to talk to the public. You talk to other scientists. Let extension do that. That was the mindset. That has changed. We now recognize, the public's important, but there's still no training in it. There's a need. It's recognized, except that's not what makes universities run. It's still grant money that makes universities run. And unfortunately, there's no grant money in talking to the people. There's no money at all. So there's a disconnect there, even though it's enormously important.
Well, Doug, thank you so much for making yourself available for us for the Pollinator Power Party, and then also just more broadly. You have a Wikipedia page. You're doing a tremendous amount of work, and I think that is going to have an impact well beyond your individual career. You are inspiring many, many people, and I'm going to put my backyard on the homegrown national park now.
Don't forget your front yard too.
The front yard, yes, of course, yes.
Okay, good.
Okay.
Well, thanks very much, Jessica. It was a pleasure to talk to you.
Thank you, Doug. Okay. Okay, that was a real pleasure to share with you, and I hope that was interesting and you learned something. And I just want to remind folks for our Twitter party this afternoon, we're going to try to get our hashtag Power and Pollinators trending on Twitter, which means we got to compete with all kinds of people, including the Kardashians and all kinds of famous people. So if you have any inclination towards doing any tweeting on Twitter, jump in 4:00 Pacific time, 7 p.m. Eastern time for an hour. And we're going to see what we can do as far as making a statement about the importance of pollinator on social media. And then come back tomorrow, same time, same place. Tomorrow, we have a beautiful lecture, about 15 minutes from a native tribal leader, and then a live Q&A with her. So she'll be on live. It'll be dynamic. We don't know what's going to happen. So join us tomorrow. And also, we're going to start our origami folding tomorrow. So break out your origami paper, and we're gonna do some folding tomorrow. So so come back. Thank you so much for joining, and share with us. We look forward to seeing your emails and your posts and all of that. Yes. Okay. Thank you. All right. Have a great rest of your Monday. We will see you tomorrow.